Hello, you found part 4 of this video for how to make a MIDI router using Python. We've got a basic control suite working now, but there's still some work to do on it. Currently, this is what happens when we turn a knob on the Arturia keyboard. Two things happen. The internal value of that knob changes within the Arturia itself. Then there's a control change message which is sent to our Python script, which then just forwards it on into Ableton. When we press a pad, it sends a note on message in the C-1 octave range. Our script recognizes this as a pad press and activates the control sweep function, which then sends control messages to Ableton as if we were manually turning a knob. The problem at the moment though is that the internal value for that knob on the Arturia is not changed. So it's now going to be out of sync with the knob value in Ableton, and this will cause the knob value in Ableton to suddenly jump when we manually turn the knob. What we'd like our code to do instead then is when we press a pad to activate the control sweep function, we want to send a message back to the Arturia so that we can update the internal knob value. This is going to ensure that both Ableton and the Arturia knob values are in sync. To do this, we'll need to send a system exclusive message. So let's first look at how these messages work before we carry on with our coding. Okay, if you remember back to the first video, we talked a bit about MIDI messages there, and in fact we did mention system exclusive messages briefly there. We said that they were a type of global MIDI message. These messages are defined by the manufacturers themselves and are specific to the particular device that you're using, but they do follow a similar format to other MIDI messages. So like other messages, system exclusive messages always start with a status byte. And for SysEx messages, that's going to be hexadecimal F0. And then you've got your data bytes, but you may have many data bytes. So we need some way of telling when is the system exclusive message over. And for that purpose, we use an end of exclusive byte, which will be hexadecimal F7. The data bytes give you information about the manufacturer ID, the device ID, that's the particular keyboard or whatever that you're using, and also the commands that you want it to do. So for example, changing a pad color on your keyboard or something. Let's take an example with the Arturia Minilab Mark II here. This information was found on a forum, so you'd have to check this out for whatever keyboard you're using here, but this one will set a knob value on the Arturia Minilab Mark II. These numbers are written in hexadecimal format. I've just taken the OX off just for simplicity here, but it starts with the status byte of F0. It ends with the end of exclusive byte F7. And then in between here, you've got your data bytes. The first part of the data bytes is all about the Arturia. So Arturia reserved those first 3 bytes there for themselves. And then the next byte is the device ID. So in other words, for the Mark II keyboard that I'm using here. And then the rest of it is the command that I want to send to that Minilab keyboard. Now this table here shows for each of the 16 knobs what the knob ID is that Arturia is using to identify each of those particular knobs. These are not written in hexadecimal, this is just a normal number format. So you can see that the first knob there has knob ID 48, the second one has knob ID 1, and so on. So we're going to need those values in our code a little later in order to identify the knob when we're sending messages back to the Arturia. I think that's all we need to know for now, so we can get on with our coding. In this next part of the video, we're going to add lots of additions, so it would be a good idea to review our code at this point. So I've had a quick look through, and there's a few changes that I'd like to make. First of all, first thing I'd like to do is change this threads variable here. It's not a very descriptive name for this variable. What it's actually doing is recording the sweeps that are running, isn't it? It's recording the CC values for those. So it might be a better idea to rename that. So if I press Control F on my keyboard, in fact, I'll do a replace here. So whenever we've got this threads variable, let's call it instead running sweeps. And I'll just go through these one by one to check that I'm replacing the ones I want. Okay, there we go. I just think that's a bit more descriptive. And if we need to add any other threads in the future, at least we haven't got a conflict of names going on at that point. The next thing I noticed is within our Arturia callback, we have this global held notes line here. This shouldn't be in the callback anymore. Let's copy and remove that. That should now be in the handle note off function. So let's put that in there. And within our control sweep function, we should have a similar statement, but this time for running sweeps, because that variable, a bit later on here, we're going to remove things from it and append things to it. Now, because we're going to be sending MIDI messages back to the Arturia, that means that we're going to have to open another MIDI port. So if I scroll down here, we can see that we've got this open MIDI out port there. I'm just going to copy all that code, and we're going to need to do it effectively the same again, but this time for an Arturia out port. So let's just replace the names of those to say Arturia out. And this output name here, we're going to have to change this as well. So why don't we call this output Arturia? And if I jump up here to our global variables section here, we're going to need to put underneath there output Arturia, and we'll just copy over this from before. Now, if you remember, we've taken off the number from the end of this. So in order to make sure that we don't get an error here, we're going to have to apply the same logic as we did before. So rather than saying if the port name is exactly equal to, we'll get rid of that. And what we're going to say instead is if output Arturia is in port, then open it. Because we've now got two MIDI outputs, I guess it would be sensible to change the name here as well for the MIDI out variable. So let's change those to something a bit more descriptive. Let's call it LoopBe out. And again, this output name here, we should probably change that. Let's change that to say, I'll use the find and replace functionality, output LoopBe. So in other words, that's what we're going to be using to go into Ableton. So there we are. These naming changes were just helpful to us because we've now got two outputs, and so it helps us to see the difference between these two. So let's just fold it all down again. Another change I'd like to make is within the Arturia callback section. You can see here that it's fairly self-explanatory what's going on. We can see there's a note on or off event between these note values, but it's not immediately obvious that we're hitting a pad, and I think it would be better to make this a bit more obvious. So there's an easier way that we can do this, in fact, because if we go back to our pad map up here, you can see that the note value is our index, which means that we can just do something like this. Our note value will be data byte 1. So we could say if data byte 1 is in pad map, what that's going to do is search through all the keys in pad map and see if our note value matches any of these keys. And therefore, if we hit one of the first three pads, it will find it, and therefore we can then go into this functionality here. Find the thread, go into our control sweep function. So I just think that's a much neater approach of doing that. So we'll make that change as well. Now there's one other change that I'd like to make, and this is bearing in mind what we're about to do. In sending messages back to the Arturia, we're going to need some way of identifying those knobs. So I'm going to set up a variable here called knob ID SysEx. So this is going to be, in fact, let's make it a list. This is going to be a list of all our system exclusive IDs for each of the knobs here. Those values there are defined by Arturia, and it's specific, I guess, to the particular keyboard that we're using here, the Minilab Mark II. But each of these numbers help us to identify the knobs. So the 48 corresponds to this top left knob, 1 is the next one along, 2 is the next one along, and so on. When we get to the end of the row, we just go down to the next row. It can be quite hard to find these if your manufacturer doesn't release them in their MIDI specification reference notes. So you may need to check some forums or contact the manufacturer of your keyboard directly if you can't find those values. So we've got the knob IDs. It would be useful as well to map the CC to each of these knobs. So I'm going to make another list here. We'll call this one knob CC. And if you remember, the first knob was on CC 102, next one 103, 104, and so on. So I just set these up myself using the MIDI control center that came with the Arturia keyboard. So we just need to make sure that whatever values you set them to, they tally with what's here. So let's just keep adding all these in a moment. So that's now every knob mapped out for the CC value. So maybe you can see where this is going. For each knob, I need both an ID and a CC, a control channel value. Now back in our pad map, can you see that we were just using the CC values? I don't like the fact that I've got the CC values in two different places. If I ever in the future need to make a change to the CC values, I want to just change it in one place in my script, not two places. So I'm going to change this pad map now so that it refers to the knob index instead. So this is now knob index. Now, in other words, that means that if I hit a pad with note value, say 1, it tells me I need to go to knob index 1. So if I need to work out what the knob ID is here, it's going to go to knob index 1, which is the second item in our list here. It will go to that value 1 there. But if I need the CC for that knob, then it will go to the second item in this list instead. So this is a much better approach. In a moment, actually, I'm going to need to add a knob value list as well, because we're going to need to keep a record of actually what the value is of that knob. So I might just do that quickly here now as well. So let's just put kind of middle of the road value for now. So we'll just assign each knob to have a value of 60 by default within our script. So if I need to refer to just the knob value now, again, I can use the index number within our pad map here to access that directly. So that's a better approach. And while we're talking about pad map, I don't think this is a very descriptive name, is it, for what this actually is? We might get confused what this is doing in the future. So maybe if we call this something like pad to knob index, maybe something like that would just be clearer for us so that we actually know what it's doing. So I just need to check all the characters of pad map that I've now dealt with. Looks like I've got 2 more. Let's just replace the name of those. So we're now calling it pad to knob index. Okay, so we've changed those two. Now we need to just change this line here as well now, because we're not actually returning the sweep CC when we do this. We're actually returning the knob index. So let's define a new variable. We'll call it knob index equals that. I'll just unfold all this a minute. I'm going to change this sweep CC here to say knob index instead. So if we found the knob index, then we're going to need to do some things. So let's work out what the sweep CC is now. So sweep CC is going to be equal to, remember we've got a dictionary called knob CC, and we just need to put into that our knob index. So that will return the sweep CC, and now we can check to see if the sweep is running. Everything else is as normal now. Oh, we've still got MIDI out here. That should have gone. Let me just check all these. Yeah, forgot to change that. So that now needs to be LoopBe out. So let's change all occurrences of that. There we go. So let's just check that this code is still running as it should do. And assuming we haven't got any bugs, it'd be good to make a backup at this point before we go any further. So let's get the script running. Yeah, all looks to be working fine. Let's try the sweep. Yeah, that looks to be running okay. And velocity sensitivity is still working, yeah, and it still stops correctly. I'll just go back into here, check we haven't got any errors coming out. Nope, that all seems to be fine. Okay. So at this point, let's close that down. It'd be good to make a backup. So let's call this backup refactoring 2. Let's call it that for now. Close that down, and we'll carry on with our main file here. Okay, so with those changes in place, we're now ready to deal with this issue of the jumping. We're going to need to send the system exclusive message back to the Arturia to tell it to update its internal value for that particular knob that we're doing a sweep on. Within our control sweep here, this is where we're sending a message into Ableton telling it what the new CC is. We should also send a message back to the Arturia. So let's define, let's have a new function here. We'll call it update Arturia knob. I'm going to pass two things to it. I'm going to pass the ID for that particular knob. Now, how do we get that? Well, if you remember, we set up a list called knob ID SysEx. I'm going to need to refer to a particular item within that. So we need to send knob index to access the right item in that list. We're also going to need to send in the actual value, which at the moment is just I. So let's now define this function. So I'll do this down here. So define function update Arturia knob, and if you remember, it's the knob ID and the knob value that we need to send in. Now, in fact, I'm just going to copy over some code again from another file here. This will just speed us along. If you remember, we're sending a system exclusive message. So this is only applicable to the Arturia Minilab 2, presumably. This is the system exclusive message that I'm going to be sending. You can see I've got the status byte, I've got the end of exclusive message byte there. The first 3 bytes here, that's the manufacturer ID. Then you've got the device ID, and then this latter part here including the knob ID, the knob value. That's the command that it's going to be sending to the Arturia. So we're passing in the knob ID, passing in the knob value, and then all it's going to do is send out this list that we've defined here, message out to the Arturia to update the value for the knob value within the Arturia itself. So we're calling this within our control sweep. At the moment, we're calling it every time when we loop around here. It's being called on literally every iteration of that loop. And I mean, strictly, we probably don't need to do that. We could just send it when we get to the end of our loop, whether that's interrupted or whether it reaches the end naturally. So how can we do that? Well, maybe we could do something like this instead. Rather than returning out of this whole function, why don't we just break out of the loop itself? So if we break out of the loop, that means we're going to get to this part here. So if we put update Arturia knob now in there, we're only sending one system exclusive message. We're not having to send lots of them unnecessarily. It's just when it needs to be updated at the end that we're doing that. So it's just going to be a bit better for efficiency. But just notice this line here, it might be that somewhere else we've already removed the sweep C from our running sweep. So let's just copy this line again. If sweep CC is in running sweeps, okay, so meaning that if we get to the end naturally without it having been interrupted in the meantime, it's going to need to remove it from the running sweeps list for us, but if it's already removed, then it won't. So let's test this out and see if it's working. So within Ableton, let's first of all put the control sweep right down there. So it did jump. We'll have to get around that problem in a moment. That's a different issue. But when I start a loop here, and now if I just stop it, and then if I try turning the dial now, you can see that we don't get a jump. Okay, so just to show that with sound this time. Okay, so we go through and then there you are. So it's nice and smooth now. So that's working well. So with just that small change, we've been able to stop it from jumping when it gets to the end of a sweep. Now it'd be useful to add that functionality with the target knob at this point, because at the moment, if you remember that when we're doing a sweep, we're always starting at 0 and we're always going through to 127, which is not ideal. We probably want to set a particular target value that we want to get to, and we probably don't always want to start at 0. We probably want to start at the current value. So how are we going to be able to do that? That'll be the focus in the next section. Okay, if you remember, we've set up this global variable here called knob value. Now, at the moment, that's not being used at all. We're not updating it. We don't know what the knob values actually are within our script. So although Ableton knows, because we sent out control changes via the LoopBe out from our script, the Arturia keyboard knows, because we sent a message back to the keyboard. But we're not updating this knob value here at all. So the first thing we're going to have to do is to ensure that our script knows what the actual value is at any one moment. So within our Arturia callback, the way that we're going to do this is we're going to have to handle the situation when we get a control change message coming in. So if we get a control change, this is going to mean, okay, if message type is equal to control change, remember this is one of the items in our dictionary up here, message types. If that's the case, what do we want to do? We want to send it off to a function, and then we want to return out of it. Now we haven't got this function here yet. Let's call this handle control change. And I think we're going to need to pass into it again the status byte, data byte 1 and data byte 2. And then we'll return out the function because we'll deal with all that we need to do for the control change within this function itself. So let's find a place for this. I'll just add it to the end here. So define handle control change. Yeah, so we needed those. Let's just copy in those parameters. So the first thing we want to do is see if we're turning a knob. So if knob turns, now what's the easiest way to handle this? So if you remember, data byte 1 here corresponds to the CC of the control change, the CC number. So we have a list here called knob CC. So we could check to see if it's in that list. That would be one approach. So we could say if data byte 1 is in knob CC, then that means it was a knob change and we can do some stuff. I'll just write pass there for the moment. If reaches here, another CC message was sent. So now it could be useful to send out a message here because we don't want to not send any other control message unless it's a knob change. So let's just check how we could do this. It's going to be one of these. And we're going to have to send in a list. The status bytes, data byte 1 and data byte 2. Okay, but what this is actually doing here is it's going through the list one item at a time to see if it's in there, and then what we're going to need to do is get the knob index from that. So knob index equals knob CC dot index, and then what are we looking for? We're looking for data byte 1. So we could do this. That approach would work. It would tell us what the index is, which then we could use to access our knob value here. So knob values, knob index, and then we can update the value to say the data byte 2. It would work fine. The only thing about that is it's not that efficient because what's actually going on behind the scenes here is in this line here we're looping through all of the items within knob CC, and potentially it could be the last item in that list. And then we have to do this all again here when working out the index. We could do something like this. Now, if it's not there, it will throw an error. And it will be what's known as a value error. So we wouldn't need to do anything with it if it's an exception other than pass. So that would be another approach. I think it's a little messy. Rather than requiring error handling, let's just code it in ourselves, and that'll be better for efficiency, I think. So we're going to put in a for loop. We're going to say for I in range, now I want to go through the whole knob CC range. So I'm going to say len, this will give us the length of the list, the knob CC list. So now what we could do is say if knob CC item I is equal to data byte 1, then we want to do our stuff. I'll just put pass in there for the moment. And what will happen here is if it gets to the end, then we know that some of the message has been sent. So we want to manage the case that if we have turned a knob, it recognizes that here. We want it to update the knob value. So knob value again, our index will be I. This is going to be equal to databyte 2. And we should probably now send out the message to Ableton. So let's say LoopBe out dot send message. We're going to send the status byte. We're going to send databyte 1 and we're going to send databyte 2. And then we'll return out to this function because we don't need to do any more. Now it could be useful to us as well, just so that we can see it happening. Let's just for the moment print it to the console. So what should we say? Knob index, we'll say I. And then we're going to say knob value and it's databyte 2. So let's run this and check that it's working. So whenever I turn the dial now, oh, there's an error. What's our error? So it's within the handle control change. We should be sending a list and we're not. Let's try that again. Right, there we go. So you can see now that it was telling me that I was turning knob index 2 and it's just incrementing the value there and I can turn it back down again. And if I try knob index 0, there we go. That's all working fine. So that's registering our knob turns correctly there. Now there is in fact one other problem that we need to consider here. If you remember, there was a jump earlier, even though we've now solved our first problem of sending the system exclusive message back to the Arturia. So that's being kept updated. But when the script first starts, the Python script is going to be out of sync with our keyboard and indeed with Ableton as well. So what we need to do now, we need to initialize those knob values at the start. So just down here, what I'd like to do is just run a function which we could call Initialise. And this function would simply do things like update any knob values that we need to do. We need it to send messages both out to Ableton and back to the Arturia. So even from the start of the script, we know that they're all going to be in sync. So how are we going to do this? Let's define a new variable here. I'll call it Initialise. I'm going to loop through one of our knob lists. Let's use for I in range. Remember, we've only got 16 knobs, haven't we? So I'll just say for I in range 16. So this will loop through 0 to 15 for our indexes. What we're going to do is we're going to update the Arturia knob. Now I need the knob ID. How do we get the knob ID? So this is going to be using our list knob ID SysEx, like that. And the other thing I need to send through is the knob value. The knob value is stored within our knob value list, which is in our global variable section above. Sorry, I'm missing a colon there. That will loop through all of the knobs and update the Arturia. Now, I also need to update Ableton. So this is going to require us to send a message out to the LoopBe. And Actually, I'd really like it if we could define that within a function as well. So update Ableton knob, I'll say. And here we're going to pass in the knob CC and also the knob value. And we'll work out how we're going to get these. Knob CC will be, if we use our list up above, we can have the knob value I again. So if we define this variable here, this function here now to do that for us. So I'll just put it up here next to the other update function. So this time it's knob CC, it's knob val. Okay, not forgetting the colon this time. And I believe we've done this earlier, haven't we? So if I just hunt for the LoopBe out, let's see where we've done this before. So handle control change, here we are. So if I copy that into our update Ableton knob, now the status byte we're not passing in here. In fact, we need to make our own up. So let's think about how we can do this. So status byte is going to be equal to, well, it's a control change that we want to send. So if I jump back over here, OXB. Now I'm going to times this by 16 because we also need to send in the MIDI channel information. So, so that's our first hexadecimal digit, and we're going to add to that. I'll just set this up in just a minute. We'll say Arturia channel. This will be the MIDI channel for Arturia, and I'll say -1 so that we have it at base 0. So back up here, let's add a new global variable, Arturia channel, and we were on channel 3. And because I want to use that same variable than what we're using up there, I'm just going to put global Arturia channel. There we are. So we've defined the status byte. The data byte is in fact going to be knob CC, and data byte 2 is going to be knob value. So this should also update Ableton. So if we go back to our Initialise function, let's just check it works. Let's run the script and let's go into Ableton. And you can see that this is in the middle. This is in the middle. That's also in the middle. Looks like it's probably worked. Let's just see if we get any jumping. Nope. So I'll just move that down there and I'll close the script again and then open it again and see whether it returns back to that position. Yeah, you can see, there we are. So now we're initializing our knob values within Ableton and on the Arturia keyboard. And they're tallying up also with our Python script here. So this all is looking good, and at this stage I think it'd be good to try and get in this functionality with the target knob. We're going to have to say, first of all, which one our target knob is. So back in this global variables section at the top here, let's add a new variable again. I'm also keen at the number of global variables we're adding here. And they all seem to be about Arturia, don't they? So if you look at my current code, you'll see that I've put it all into classes for that reason. I just think it's a better approach. It does add to the complexity, but it makes it more organized. So we'll stick with this approach here though. So target index. I want to make this top right knob here our target knob. So that's going to be index 7 because it's knob number 8. So we want to aim for that target within our control sweep. So let's open up the control sweep function. And if you remember, we're going through a for loop at the moment, and we're going from 0 all the way through to 127. But we don't want to do that. What we actually want to do is start at our current value and end at the value which the target knob has, don't we? So how are we going to do that? Well, we're going to need to work out what our current value is. So let's do something like this. Current value equals, now do we know what the knob index is? Yes, we found it up here. So it's a fairly easy thing to get our current value. We just need to go knob value and then pass in the knob index. So this will give us the value for the particular sweep that we're running. And the target value is going to be equal to, again, it's going to be knob value. But this time it's target index. So we just defined that above. So target value is equal to that. Now, as we look at this loop, we might need to sweep downwards as well as upwards because our target value might be lower than our current value. So the easiest way that I can think to do this is, why don't we define a new variable called increment value? And we'll make this equal to our target value minus the current value. And now it depends on how fine-tuned we want to make this. Why don't we say, do it in how many steps? I'll just put divided by transition steps. Okay, let's define that variable up above. I think 60 might be a bit overkill, but let's go with that for now. Remember, we've got a maximum of 127 different values, so effectively we're definitely going to do half of those values, so it probably is overkill, but we'll go with that anyway for the time being. So if we want to make it more efficient later, we could just change that transition steps. It may well affect the time that the sweep takes to complete as well, so we just need to think about that. But what we can do now then is change this for loop. Let's just comment that out for the moment. We're going to make it a while loop. So what we'll say is while I is less than transition steps. Let's just define I up here. So we'll say I equals 1. And when we get up to 60, we're going to stop here. But let's also say this. Remember, we had to break out the loop earlier, didn't we? So before we said, is sweep CC not in running sweeps? So why don't we just say sweep CC must be in running sweeps? Okay, so that just makes our code a little bit neater there. So we're going to keep looping around and we're going to keep sending messages out to Ableton. Then we're going to sleep. And then we're going to need to increment I by 1. When the sweep ends, we're going to update the Arturia knob here. Now remember, we were using the value before I. We're going to need to change that in both cases here. So let's just change this so that it now says current val. We'll do the same here. Current val. Now I need to update the current val within this loop. So current val is equal to, we're just going to keep adding to this value. We're going to use the increment val here. So this may actually be sweeping downwards. It might be taking away from this value if incremental val is a negative number. But alternatively, it's just going to be adding a small amount to our current val. Strictly, this won't be an integer anymore, but I think that our send message will still be able to cope with that. We'll find out now. From memory, I think it can cope with that well. So let's run this and see if it works. So back in Ableton. Okay, I'm just going to turn the knob value all the way up. We can't see this change yet, can we? We'll worry about that in a minute. So if I press a key, press the pad, lovely. Now let's try turning the knob down. Turning it again. Right, there looked to be a jump there, but nonetheless it does seem to be following the target value along, doesn't it? Yeah. It suggests that our Python script is out of sync with either Ableton or Arturia at some point, which is why we're still getting jumps here. But nonetheless, the target value part seems to be working. Let's just add something so that we can see our target knob changing. Probably the quickest thing to do is just add an audio track here. I'm not going to use this audio track for anything. It's just so that we can see the knob turning. So I'll map that there to our target knob. So now when I turn that knob, you can see, yeah, it's changing. So we can just see we've now got a visual of what our target knob is doing. So back in VS Code, let's try and problem solve why we're still getting a jump there. I'll just close this down. Yes, of course. Within our control sweep, can you see that although we're sending a message out to Ableton, we're updating the Arturia knob. At no point are we actually updating the current value within our Python script. So there are two places we could do that. We could either do it at the end here, or we could do it as we're going along. For efficiency, it would probably be better to do it at the end here. Let's just think, are we ever going to need to know it mid-sweep? Yeah, potentially we might in the future. So let's imagine sweep is already running and then you turn a control knob. Certainly in my version of the script, I can stop the control sweep when I turn the same knob. And in fact, it could be useful to have that in this script, couldn't it, later? So although we're taking a slight hit on efficiency of our script, it will be worth having this in here. So what we're going to do is say knob value, and what are we using? Is it knob index here? Yeah, knob index is equal to current value. So what this will do is just make sure that at any one moment our knob value is the same as the current value within our script. Now let's try running it now. Yep. So back in Ableton, I'll turn that up. Yep. Let's just go back into our MIDI channel so we can see the changes. I'll turn that knob there. Yep. Target knob's working fine. And now no jump. Lovely. Okay, it'll be worth going through the rest of our script to see if we've got, in fact, any other issues like that where we're not updating the knob values. I don't think there are, though. It's either you're manually changing one of these knobs by turning it, or it's within a sweep CC, isn't it? So I think that's probably all we need to do there. There is one other change I'd like to make to this control sweep, and then I think we should probably wrap it up. So let me show you what happens at the moment when we turn a knob in the middle of a control sweep. Let's just set a control sweep going. So I'll turn the target knob there and I'll fire the control sweep. And now I'll turn this knob. And you see it was competing. And we don't really want it to do that. I think a better functionality would be if when we turn the knob in the middle of a control sweep, it realizes it needs to just stop that, override it, and allow the user to manually change it to where they want it to be. So let's have a think about how we're going to do that. So back in VS Code, we need to remove our knob CC value from the running sweeps list. So if you remember back up here, we're keeping a record of all the sweeps that are in progress here with our running sweeps. we're going to need to remove an item from that list. So let's see how we can do that. If you remember, back in our Arturia callback, we're managing the case of a control change here. And it's sending us to this handle control change function. So let's go in there. Handle control change. So let's just open all that up. I'm using a VS Code keyboard shortcut there. That was Control K right bracket, and that will open up recursively all the things within that function. So at the moment, we're going through this for loop here to see if we can find the knob. If we find that the knob CC corresponds with data byte 1, we know that this is a knob change, and therefore we're updating the value here. Now what we also want to do is check whether it's in our running sweeps variable. So I'll do that at the top here. So I'll say if data byte 1 is in running sweeps, what do we want to do? Well, we want to remove it from running sweeps. So we'll say running sweeps dot remove, and it's data byte 1 that we want to remove. So I'll just make this a one-liner because I don't think we need to do anything else with that. It can carry on through this procedure. It can update the knob value within our script and then send out a message into Ableton. So that's all fine. But I'm still expecting to see a jump with that change. So let's fire our script again. Sorry, that was already running. Let's get it going again. So I'll turn that down, I'll turn the target knob up, and you'll notice here then that when I get a sweep going, if I turn the knob, it did stop it, but did you notice the jump again? Now, the reason for that jump is because we made a decision earlier that it would be better for efficiency, back in our control sweep function, if we updated the Arturia knob outside of this loop. So it's only when it gets to the end of the control sweep that it sends a message back to the Arturia keyboard. Now, that's not going to work for us anymore. We're going to have to now put that within the loop itself. So in this line here, we're sending out into Ableton. This line now will send it back to the Arturia, and we're updating the knob value within our script. So let's try it again now. So I'll close the script down and run it again. And start our sweep. And now if I turn a knob now, you can see it stopped it and there's no jump. Perfect. Now, we could go on forever here, couldn't we? So I think we should think about wrapping this up. Okay, I've had a quick look through the code. There are a few final changes I'd like to make just as we finish off now. I've noticed a few typos, so let's deal with those first of all. So there was this variable here was spelt wrong. That should be knobval. So let's just use find and replace to change both recurrences of that. I've also noticed within this update Ableton knob function here, we don't need this line global Arturia channel because we're not in fact changing the value of Arturia channel within our function here. So I'm just going to get rid of that line. And in fact, this is a strange way of doing it. Why don't we just change this to say B0? It just means that we've got one less calculation to do now. It'll just make it slightly more efficient. So any status byte that is in the range hexadecimal B0 through to BF, it will pick up there. The second hexadecimal digit is just by adding the Arturia channel as before, but I think that's just a bit neater. And a couple of other changes that would be good to do at the end of our script here, when we come to shut down our procedure after this input line here, it would be good to just make sure that we tidy up our resources before we shut down the script. And I think one particular issue would be, what if there's already a note holding, particularly on the Arturia keyboard, because remember, it's not registering note off events in the normal way. So it would be good actually just to double check our held notes list up here. Remember, held notes is keeping a record of any notes that are running on our Arturia keyboard. So it would be good to just go through and turn any notes that are still running. So we'll call a function called all notes off. And all we're going to do with this function is go through our held notes and remove any that are still on. So I'll just add this down here. So all notes off, and we'll loop through our held notes. So for in fact, let's do it like this. For notes in held notes, now remember, held notes is recording the data byte 1 values. Yeah, it's the note numbers. So actually, let's, rather than calling this note, let's call it note val. So for note val in held notes, what do we want to do? We want to send a note off message. So this will require us to use the LoopBe out dot send message. We're going to send a list. If you remember, we need to send our status byte. We'll write that in just a moment. We need to send of a particular note value. So this will be our note val here, and the velocity of that note can just be 0. So let's just write the status byte that we're going to need. So status byte and I'll just check quickly up here the message types. So the note off is OX8. So we'll write OX8 plus, remember we're on the Arturia MIDI channel, so let's just add that and take away 1 to make it base 0 again. So now this will loop through all our notes that are currently being held. It will send a note off event on the right MIDI channel for that particular note val. Yep, so that's fine. The last thing to do, this is just good practice, we want to close our MIDI ports really when we end the script here. I mean, strictly it will happen if the script closes correctly anyway, but it's good practice to make sure that we do this. So the easiest way to do it would just be to delete the actual object, because RTMidi will do the tidying up, closing the ports for us. So we've got an Arturia out, we've got an Arturia in, we've got a LoopBe out, we've got a Kawai in. So those are all our MIDI ports that we're going to need to close down. So at this stage, I'll just do one last check that it's still working. So back in Ableton, get a sweep going, turn the target knob. Yeah, all looks to be working fine. Now, when we actually come to run the script, we probably don't need all this logging of the messages that are coming through. So why don't we just check all our print statements here, and we'll see whether we want to keep any of these in. If we don't want them, maybe we'll just comment them out for the time being. So yeah, so we don't need that one. Comment that one out. Don't need the Kawai message. Comment that one out. That one's already commented out. We don't really need that one. Let's comment that out. You could remove these, but if you want to look at them again quickly later, it's easier if they're already written in and you just uncomment them. It would be useful to know that we've opened the MIDI ports, wouldn't it? So we'll leave these ones in. Another useful feature you may want to add, which I've added to mine, is if you remember whenever we're doing a control sweep, let's just turn this back on again. Whenever we're doing a control sweep at the minute, there's no visual indication of a sweep happening on the keyboard itself. So if I just get that going, there's no indication on this keyboard here that that was sweeping. On my version of the script, I've got these pads flashing. I think it would, we could go on forever with this, so I'm not going to show that. But if you did want to look at how to do that, you could go onto the GitHub page, find my file here. But when you open mine up, you'll notice it does look a little bit different. I've organized it into classes instead. So all of the functions, I've got 2 functions as global functions here, but most of the functions are within a class. So if I go into, say, the Arturia class, you'll notice here that it's got things like update pad color as a function here. And if you are looking for the SysEx message that you need to send in order to change your particular pad, that's what it is. Again, I found that on a forum, but it would save you some time if you're using the same keyboard as me there. So you might want to have a look into that file. I should just say as well, the Roland class is what we were calling Kawai. When I first wrote this, I was using a Roland keyboard for my master keyboard, so that's why that says that there. I guess one other thing as well, if you do try running my script, it will ask you a question. Do you want to run this in bass mode? All that's doing is within the Roland class, I've actually got functionality so that if the bass player isn't there that morning, I can play bass myself on the keyboard. And it's good to, when I'm playing bass with my left hand, I don't really want a piano sound or string sound or organ sound in the same pitch range as the bass. So I've made it so that I can turn the bass up with an expression pedal, and as I turn the bass up, it actually turns the piano and the strings and the organ down within that particular pitch range. So that's coded in using Python here. So if you wanted to look at how you do that, you could again go into the Roland class, and it's, I think, just within the callback function probably at the moment. So you can have a look at how that's working. So I hope you found this video helpful and it's given you some ideas for how you might use Python in your own setup. I wish you well with it. Bye for now.